Hi, this is Sarah Parker, and I'm going to be doing a code explanation of our final assignment, number 10 in CPSC5010. This is expanding on the previous assignment that we just did, assignment 9. The first one is that we're going to be implementing a template class for a stack, and it's just mimicking what the stack does in the computer with memory, with a first in, first out. So anything that we add to our class stack, the first in will be the first out. We accomplish this by creating a template class called stack, and we are going to have a private variable, which is going to be a vector of our elements, and that's going to store all of our elements. And then we have some public methods. So we have our push, which is going to pull through a reference for our stack and add the element. And then we're going to call elements, the vector, and we're going to push back our new vector. So we're going to add that here. Pop is going to take the top element from the stack, so that last one, first in, last out. We are making sure that it's not an empty stack, and if it is, we're going to throw a runtime error. As long as it isn't, then we're going to call elements.popback, and these are just built-in methods. So it will pop back or take that top element from our stack. And then from here, this will take the top element without removing it or altering it. So we're going to call our template top, and then if it's empty, we're just going to say it's empty. We cannot get the top element. Otherwise, we're going to return elements.back, that last one. To make sure that this works, we're going to implement stack as an integer, as a string, and as a float. So here's where we're going to call our first object, or create our first object of integers. And we're going to push in 3 different numbers, 789, 26, and 3. And then we're going to do print to the terminal what that top element is, which should be 3. That's that last one we pushed. We're going to pop our element, which should be the last one, which is 3. And then we're going to recall the top element, which should be 26. So that's just, we took our element, that last one out, and then we added, then we called the new last element, which is 26. Essentially, we're doing the same thing with our strings and our floats to make sure that it works with different data types. So we're going to push the first string, which is CPSC5010, and then we're going to add C++, and then we're going to print out the top element, we're going to pop it, and then we're going to reprint the top element. And then we're repeating this all with our floats. And the F is just to designate that these are float numbers. So, well, I already ran it, but let's just clear it and run it again. So it compiled just fine. And then now we're going to call it. So if you go back up and look here at our ints, the first one that we added was 789, 26, and 30. But the only thing that we're asking it to print is the top element, which is 3. Then we pop that top element, we take it off, so then the next one is 26. And this is just repeating here. So the top element was C++, but then we popped it. After we popped it, then our top element was the 5010, and then the same thing with the floats. So this is just demonstrating how you can use a template class with different data types, but your methods will still work because it's off a template class. So that's pretty cool. And then the second assignment was just an expansion of overloading operators for complex number classes. So we were asked to create a class with real and imaginary parts, and then overload the addition, subtraction, product, and division operators to perform arithmetic operations on complex numbers, and then also overload the output operator, which I'll show you in a second, to print those complex numbers in the format A plus B with an I at the end to show that it's imaginary. So this is just the same thing we did in assignment 9, but a little bit more complex. Hence, complex. Our class is called complex, and then we have our private variables, which are doubles, a real and an imaginary part. Our constructor, we're initially setting our real as 0 and 0, and we're assigning that here and here. And then we're going to overload our plus operator, our addition operator, by calling that reference, and then we're going to return a new object of complex with real plus other real. So that's whatever we have assigned plus the new one that we're calling, and then our imaginary plus our other imaginary. We do the same thing for subtraction. Multiplication gets a little bit more interesting because you have to perform some additional arithmetic calculations in order to get that, but essentially it's real times our other real, which is here, minus our imaginary times our other imaginary, and then real times other imaginary plus imaginary times other real. And that's how we return a new complex object with the numbers that were multiplied from our other complex object. We're doing the same thing with our division operator. Again, it's just a little bit more complex, but we're essentially returning our complex object, and it'll have one real number, one imaginary number, and that's just gathered from doing these calculations. Here is where we are overloading our output operator. And so here we're just calling our reference to OS and then a reference to our complex, which is called C. So here we're just going to have OS, and then we're going to have our C times real, which is calling that variable that we have up there, and then C times imaginary as long as it's not 0. And then we'll assign that to our abstract and I. And then we're returning that to OS, which will print in our output. So to demonstrate that, we are creating two complex objects, complex 1, complex 2, with 3 and 4, and 1 and -2. So our output is just to show what C1 is, and then to show what C2 is. And then here, we're going to create new complex objects with the sum, and that's calling C1 plus C2. We don't have to call any functions. We are just literally using this operator, which will add C1 plus C2 for us because we have overloaded the operator up here. So it's calling the two objects and then creating a new object as a result. We're going to do that with the difference, the product, and the quotient, and then we're going to output that C1 plus C2 as the sum, and it's going to have that formatted like this with our real and imaginary numbers because we are overloading that output operator. So okay, so the first line, C1, is 3 plus 4i, and that's just designating that 4 is the imaginary number. So 3 and 4, our second complex number is 1 and -2, which we have 1 and -2. And then to add C1 plus C2, we get 1 minus 2i. So wait, sorry, I read that wrong. 4 plus 2i. So that's 3 plus 1, 4. And then we're going to add our imaginary parts, 4 minus 2, which is 2i. And then it completes it for subtraction, multiplication, and division. So that is our overloading of our complex overloaded operators. Man, can't even get that out. Okay, and then the last one is to, let's just clear this out, is to create a singly linked list with an overloaded operator. So this time we were asked to create a singly linked list with basic operations and then to overload the output operator. Optionally, you can overload the addition operator to concatenate two lists, which I did. So here is our linked list. So a linked list essentially consists of a node, which is going to be the pointer for keeping track of all of our data in a specific order. So we're going to start by creating a template class so that you can use this linked list with integer strings, blah, blah, blah. And then we are going to create under our private variables a structure, and this is our node. This is what's going to keep track of everything. So we are going to have the template data, and then we're going to have a pointer to next, and then we're going to create our constructor. So the value gets assigned to data, and our null pointer gets assigned to next. So we want to start it empty. We want to start it null. And then under our private, we also have a pointer to head. So that's going to keep track of that first node, essentially, where that first node is. So then in our public, we're going to create our linked list, and we're going to create our head at null pointer, and we're going to have our destructor. So we have our constructor for our linked list and our destructor for our linked list. And then we're going to create these methods or functions. Insert at end, we're going to add a value. Delete by key, we're going to find a specific key, and then display the list. And here's where we're going to overload our operator. I'm going to pause for a second. Okay, sorry, had to take care of my kiddos for a second. Okay, so these are the functions that we're going to be creating. This is our overload operator, and we've demonstrated that in the previous one, but essentially when we do our output, we are going to make sure that we don't have an empty list, and then we're going to create a pointer called temp, and that'll be our head, and while the temp is not empty, so while our head is not empty, then we're going to assign that to data, and we're just going to scroll through that, not scroll through it, but loop through that until it does become empty, and then it'll be null. So our last one will always say null, and that's the OS that we're calling here. And then we're going to overload our addition operator, which we'll show later, and then we have our destructor. So we want to go through our entire node until we find our null pointer, and then we're going to delete everything. So that frees up our dynamic memory. Okay, so here's the implementation. So this is our linked list to insert at end, so the implementation of that. So this is going to be putting a value at the end. So we're creating a new node, and that new node is going to contain the value. As long as the head is not empty, so as long as this is not an empty linked list, then we're going to go through here. We're going to use our while loop, and we're going to assign temp to head until we get to an empty spot, and then we're going to assign the new node to the head. So we're going to scroll through all of our nodes until we get to the empty one, and then we're going to create a new node, and we're going to assign that as the new node right here, or next as the new node. And then we're going to assign our value as the new node. So where this is, the new node is going to be the value here. So essentially that just makes everything stay where it's supposed to be. It's linked, and we have our pointers that are pointing to the next node, and when we create a new node, then that the old one will point to the new next. Here we're going to delete a node by the key. So this is the key, whatever value it is that we're looking for. So essentially all this does is make sure that it's not an empty linked list, and then we are going to go through each node and data type to see if it matches our key. If it matches our key, then we're going to delete it, and that's the whole point. If it doesn't match it, we're just going to continue on to the next one. But if we delete it, then we need to take our old pointer and move it to the next one so that it's not pointing to a deleted node. So that's what this is going to do. We're going to identify the node that needs to be deleted and then delete it, but we also are going to assign the pointer to the node after that to make sure that everything stays the same. And then you're just using this to display the list. So we are using our overloaded operator, and we're going to dereference this, and we are going to print out our list. So pretty straightforward. This was the optional one to concatenate, or two strings. So we're going to take our two lists and we're going to overload our operator, and we're going to make a new linked list here, and we're going to find our node, our pointer to temp, and make that the head. So essentially what we want to do is we want to take our first list, we want to traverse it until we get to the end, and then when we get to the end we want to stop and we want to add our second list to that. So that's what this is doing, is we're going to insert our new list at the end, but we've got to make sure that we do that, and then we keep all of our pointers in line as well. So here is a linked list. We're going to call it list 1. It's an integer list. We have that here, and we're going to insert at the end 10, but then we're going to insert 20 and 30. So our first list that'll be printed should say 10, 20, 30. And then we're going to do the basic hello world. We have two that we're adding, so we have our linked list here, and then we're adding hello and world. Now for list 1 here, we're going to delete by key. So we want to delete 20, so our new list should say 10 and 30. And here we're going to show how to concatenate the two lists. So we're creating a new list, list number 3, and we're going to make it 40 and 50. We're going to print out the list just to show what it looks like. And then we're going to show what the concatenated list of 1 and 3 should look like, which should say 10 and 30 because we've deleted 20, and then 40 and 50. So if we've kept all of our pointers correct and deleted them appropriately when needed, that's what we should see. So compile it and keep our fingers crossed. Okay. So our first list, 10, 20, 30, null. Remember that was where we overloaded that operator. Here. This is where we overloaded the operator to add null to the end. So that way we know we're at the end of our list. List 2 is hello world, null. List 1 after the deletion is 10, 30, null, because we deleted it by the key. So our key was 20. So now we have 10, 30, null. List 3 is 40, 50, null. And then our concatenated list of 1 plus 3 is 10, 30, 40, 50, because we deleted that 20 by the key. So this is just a singly linked list, meaning that we are just pointing to the next one in line. We are not pointing to previous ones, but this is how you would keep it all straight, by pointing to the pointer in the node, and then you have a separate data value for the second part of it. So still complicated in my brain, but I think I understand it for the most part. This was the final assignment for CPSC5010. Thank you to anybody who has tuned in and would love some feedback on linked lists if you have them.